So I'm going to talk today about fire and life safety solutions for extreme heights. I'm going to talk about the solutions and some ideas about how we can reach those solutions, but I have a personal belief that fire engineering is a topic which touches pretty much every design and operation aspect of tall building design. And I think fire engineers need to be educated about why we build tall buildings. And if you don't understand the why, then it's very hard to design buildings that are actually going to be safe and function properly. So I'm also going to talk quite a bit about what I think is going to drive tall building design in the future, particularly extremely tall buildings. So this is where we sort of currently are in tall building design. This is the CTBUH 20 Tallest in 2020 poster. Highly recommend it. If you haven't got it, you can go and buy it from the stand and you can get access to it. And where we can see we are at the moment is that we only really have sort of two buildings which are, or do, or will really break through the megatall 600-meter barrier. Now, I appreciate that the Shanghai tower next door does go over 600 meters. 632, I think it is. It just sort of nudges over. But really, it's the Burj Khalifa just pushed the limit way up there at over 800 meters, and the Kingdom Tower will break the 1,000-meter mark as well. So the question is that what's going to happen to tall buildings in the future? Are we just going to continue to build more and more tall, monolithic towers? Virtually all of these buildings that you can see, they're all a simple monolithic tower form. Now, generally, that's driven by things like plot size and things like that. But actually, that isn't really the issue for buildings like the Burj Khalifa and the Kingdom Tower. You know, the map, the background, we'll come back to that again in a minute, but that's a plot of the population density around the world. And the world's two tallest buildings haven't been built or won't be built in the most densely populated part of the world. They don't feel the land pressure that you feel in places like Bangladesh or London or New York, okay? They've been built tall because it looks great and it adds land value. So are we going to continue to do that, or will something change? And if it does change, what are the implications of that on fire and life safety? I'm always a fan as well of understanding where your fire codes come from, because if you don't understand where your fire codes come from, and where your design principles come from, then how can you go forward and design for new building typologies? Okay? So there's a photograph of a painting of the Great Fire of London. You could put up a similar painting of the Chicago fire, perhaps, if you want, for the US, but we derive so much of our urban planning, particularly fire codes, from this incident. And it's not just the UK that derives its fire codes from this incident. The separation between buildings, the use of certain materials in the construction and the external of buildings is driven by a fire back in the 1600s. Okay? This is the Stardust Disco fire in Ireland, a terrible catastrophe. And this, along with a number of other similar fires at the same time, this drove the fire safety design of large or of assembly spaces. Now, the thing is, it took a disaster like this to lead to changes in the fire code. Okay? It took a disaster like that to lead to changes in fire codes. US example, MGM Grand. Interestingly enough, a lot of the same issues you had in the Stardust fire to do with combustible ceiling tiles and combustible materials as lining materials contributed significantly to what happened at the MGM Grand, with the added problems that you had passage of smoke and fire through the building through ventilation shafts. And we really started to take tall building fires a little bit more seriously with the MGM Grand fire. But in terms of super tall and mega tall buildings, you know, fortunately we haven't really had a big fire disaster, except of course for the one on 9/11. What happened about sort of 30 years ago now is, in some places around the world, we started to move away from disaster-led fire code changes. Okay, one of the first places was the UK. in the early 1990s, we changed our building regulations, and we no longer tell you how you have to design a building. We don't put forward prescriptive requirements. We set forward some functional objectives. And you can sum up the entirety of the English building regulations by simply saying, make the building safe. Okay? There is guidance available about how that might look for a standard, typical building, but that's very historical and backwards facing. It doesn't look forward. Following the events of 9/11, there was the very large study by NIST, and we started to move forward on a more global platform to think about performance-based design. We started to ask questions like, what went wrong? What could we do better? How can we think about what might go wrong in the future? Okay? And that method, that performance-based design method, sits at the heart of the most recent guidelines for tall building design, and it starts to ask questions in a proactive way of, what if something happens? Now, this approach allows us to respond to new typologies. So if anyone comes along and tells you, we know all the answers for designing tall buildings at extreme heights, then you really shouldn't listen to them, because you don't know them yet. We don't know how these buildings are going to function, how they're going to operate. We don't know what the main drivers are for these buildings. And until we know all of that, we can't really work out how to make them safe. But we can use a performance-based, a proactive design approach to work out what the safe solution will be for each building. So, what is going to drive new building typologies? And then from that, how's that going to change the performance-related fire designs? This is a nice little chart. This is US commutes. Now, the average American spends between 10 to 15% of their life commuting. What a ridiculous waste of time. Okay? You drive all the way to an office, you sit in the office all day, you get in your car, you drive all the way home. Maybe you take the subway. You can do lots of work on the subway, can't you? Rattling around, rubbing up against other people's sweaty armpits. It's a lovely way to travel, you know? We've got so many sheltered spaces where you can work these days. Why do we still go to offices? Is the office dead? There was a presentation this morning which made the point that in 2000, 83% of the tall buildings were commercial-based buildings, commercial office buildings. By 2013, that had dropped to 40% of the tall building stock was commercial office buildings. So is the office dying? Is the office on its way out? Well, you know what? Not really. We did some work with Google recently. We looked at their office typologies. We looked at what they wanted to get out of office buildings. And it turns out the office isn't dead. But the more forward-thinking office users, they think of the office as a big sort of water cooler moment. And it's more like chickens round a feed station in an open plan area. They want people to be able to come, to congregate, to commute, to come in and be together. But, you know, the chickens and the commuters can actually go off and work elsewhere as well. They can go and find their privacy. They don't all have to be crammed into the same box to do their job. Now that means that we probably don't need as much concentrated office space in the future as we have now. And are we reaching an end of an era where we build tall, monolithic, iconic commercial office buildings in the middle of our cities? I mean, for sure, there's countries which are still catching up on this. You know, there's places in South America, there's parts of Asia where we're still building tall commercial office buildings. But I'm quite happy to bet that in the last 10 years, we've seen a radical change of London's skyline. I don't think you'll see that sort of change again in the next 10 years. I think instead what you'll start to see is a lot more refurbishment of buildings. And you'll start to see tall buildings starting to be much more mixed use. There's been a lot of talk about that. It's very much seen as the mixed use is seen as the future of tall urbanism. And I think we'll see a lot more of that in cities like London. I think we'll see a lot more of that in cities around the world as the pressure comes on. There's been much publicity last year particularly about the changing population demographic. We've passed the point where more than 50% of the world's population lives in urban centres, so we've become a more urbanised society than we ever had been before. We predict that sort of by the time the population levels out, and it is predicted to level out, we'll reach about 9.5, 10 billion people. But the big change, of course, is that so many more of those people are going to live in cities. We've got to find a way of all these people, an extra sort of 6 billion people, to live in cities. Okay? Now, We could just fill in the blanks. We just make the cities bigger. There's quite a bit of blank space around the world. But the interesting thing is that some of the most concentrated parts of the world, okay, so areas like Bangladesh, for example, okay, they don't have many tall buildings, and yet they are immensely populated. We face climate change challenges. This will drive the movement of people and migration. You see Bangladesh there, it's one of the most heavily concentrated population densities in the world. It's also one of the most low-lying countries in the world. Okay? We may well start to see waves of climate refugees pushing towards southern Europe, pushing south below into sub-Saharan Africa, and pushing out towards Asia. This could well happen, and this could mean a huge increase in the rate of urban development. This is the current response to that problem. Okay? I think it's a disgrace that in the modern world we still have slums like this. And as we bring more and more people in, whether they're driven by climate, whether they're driven by economics, or simply by birth, is this the right response? Do we just stack the slums up and create vertical slums? Is that a credible response to the problem? I don't think it is. And if all these people are going to commute and go to work in cars and find occupations in the city, then are we going to reach, or have we already reached, the limit of our horizontal planning? Okay? You can't, it's virtually impossible to commute in some cities these days. Okay? You hear about people taking 2-3 hours each way to commute. That's simply unsustainable. If you think 10 or 15% of your daily life, of your waking hours being committed to commuting is bad, you wait till it's 50% of your waking hours just stuck in a box trying to get to work. That's completely untenable. So we have to bring the work environment and the living environment together. And that's what tall buildings will do, particularly super tall buildings. So this is a rational response to that. This is the China Broad project, which thinks about these problems. It mixes in a true mixed-use building in a megatall structure. It mixes living, mixes social accommodation, leisure space, and working accommodation. Okay? It's quite likely that these buildings will be the first time that you'll have human beings who could quite literally be born, live, work, and die in the same building with never leaving it. Is that so far away? Well, only we saw the news recently. There's something like 60, 70 people who've lived on the Google campus for more than 3 months. If people could do that on the ground plane, they can do that vertically as well. It's not that far away. It is coming. Absolutely, this is coming. And if we don't get this right, then, where do we end up? What will these buildings look like? Okay? If you want to start building bigger, taller buildings, they're not just going to be towers. They are going to take on much more pyramidal, blocky forms. They're going to change the aspect ratio of these buildings. We're going to recreate the ground plane higher and higher and higher up through the building. We're going to treat vertical transportation, vertical movement, very much as something which is part of the urban planning process. Okay? If we're not careful, we end up with the Judge Dredd future, the megacities. These are really just conjoined towers with big atria in the middle, linked together to make use of all the available floor area. Okay? So what are the fire safety challenges of doing that? How do we tackle those using a proactive approach if we have these mega tall, mega cities in the sky? Okay? Put away your code books. This is how it's done. You have to think about what are the risks, what are the objectives, work out performance characteristics, and come up with solutions. These solutions will be bespoke to each of these vertical megacities. Okay? Now, the text in this slide's a bit small, I think it's fair to say. So here's an edited version. You can read the full version in the text. If you start with a low-rise building, this just looks purely at the performance characteristic of, do you tell people there's a fire, and do you evacuate them? If you've got a low-rise building, when you've got people close to the fire, you know what? You raise the alarm, they get out. The medium-rise building, yeah, you do the same sort of thing. A tall building, well, yeah, you probably still do that. Super tall buildings, yep, you do that. And the same in hyper tall buildings. So whenever there's people close to a fire, you want them to get away quickly. Now, you might start to think that as you start building taller, that you're going to evacuate more people because there's more people at risk. And when you're in a super tall megacity, then guess what? You haven't just got people at risk above you, you've got people at risk to the side of you as well, through openings, atria, garden spaces. So when you've got people who are close to the fire, but they're a little bit separated. Maybe they're in another room, another pod across the way in your megacity. Well, as you start to move to the super tall and the hyper tall buildings, you don't actually move those people. You let them know, perhaps, there's a situation, which you might do in a tall building. In a super tall building, you might inform them that something is going on and to stand by, but you move them later on. You defend in place. You leave people in the building that's on fire. And that's going to have to happen. Because if you take a city, if there's a fire in the building next door, you don't evacuate this building. If you're in the suburbs and your neighbour's on fire, or across the street's on fire, you don't evacuate. But that process, that horizontal separation, when that's extended up into a megacity, in theory, you'd evacuate those people, but you can't because the numbers of people involved are huge. And also the implications of getting the evacuation wrong and telling people to evacuate when they don't need to are huge as well. So interestingly enough, as we start to build taller and taller buildings, actually the number of people, or certainly the radius of which you raise the alarm and start to evacuate people, actually goes down. Okay? Because you can't tolerate the disruption, you can't tolerate the interference of that. We need to think about legacy. There's a lot of talk in one of the morning sessions about legacy design and how we cope for that. Well, if you take a city like London at the bottom there, or Dubai at the top, it took London 115 years to change between those two images. It took Dubai 20 years to change between those two images. And in 20 years' time, Dubai will look completely different. Will London look that different in 100 years' time? Well, we'll see about that. But that change that you see in the horizontal urban grain is going to start taking place vertically as well. Not just one or two floors changing tenants. I'm talking about massive chunks of a huge megacity changing. How do you plan for that? How do you plan the infrastructure for that? How do you plan the firefighting for that? When your firefighting is no longer driving around city streets and plugging in and going up through a building. That's just not fast enough or efficient enough for firefighting in these big tall buildings. But I have faith in humanity. We can make people safe from fire in an isolated situation like space. Okay? That might seem like an extreme example, but if you've got a building that's 3 or 4 kilometers tall, and you've got a pod of 400 or 500 people living in that building, separated by 10 or 15 meters from the next pod above and below, in a megacity structure, believe me, that's no different than the way these guys have to live. The detachment and the ability to rescue people and the way they have to fend for themselves is very, very similar. We've actually done building designs already which take this sort of stuff into account. I've got a bit of faith in technology as well. Okay? We're starting to see the testing now of drones and remote operated vehicles for helping construction. Okay? Again, Google leading the way. One day they'll do everything perhaps. They are already talk about delivering aid packages and delivering food and groceries and retail to your doorstep using these UAV and unmanned drone systems. Okay? If we're going to use them for construction, which we may well do, we could also use them for things like firefighting, maybe even for rescue. It's quite a novel idea. There's a lot of talk about, and there's a lot of use these days of remote vehicles for traditional firefighting activities to reduce the risk to firefighters. If you've got a complicated megastructure, you can't have firefighters sitting around doing nothing all day, and it's very hard for them to be able to predict how they'll be able to get to a fire in a megastructure. So maybe we use robotic firefighters that can sit on standby. Okay? And that's exactly what these are. Now, the one in the bottom right there is just basically a fire extinguisher on wheels. But the one on the left, that's the US Navy's vision for how they're going to fight fires in submarines in future. Okay? Now think back to this image. You think about the risks and the fire hazards in a submarine, a separated space, nowhere to run to, a very, very dangerous environment. Now, you put those pods together into a megacity. So maybe robotic firefighting is the future. Maybe that's what we're going to be looking at, instead of sending firefighters into building carrying hoses around and the such like. So I think there's lots of answers out there. I think there's lots of opportunity for technology to deliver. I don't think we need to worry too much about advanced technology necessarily for things like escape. We can talk about using lift evacuation and the such like, but when you've got a horizontal capacity to escape, like in a large megacity, then lifts aren't the only answer. I don't think we should abandon things like staircases. I don't think we need to issue everybody a jetpack just yet. You know, it's a bit inconvenient, a bit bulky to carry around. But I think some of those solutions might actually start to emerge for getting firefighters and rescuers to buildings instead, rather than using stairs and elevators. Okay? So I think there's lots of challenges, but I think at the core of this is we've got to move to a point where we're studying these buildings, not from a viewpoint of current codes and current standards, but by simply asking, what are the risks? How are the buildings going to be used? What are the legacy challenges for these buildings? And making sure that as we design the buildings now, those legacy challenges are recognized and taken into account as part of the design process. We can't do what we've done as a building industry for so long, which is design a building, get it signed off on the day the design is finished, signed off on the day it's constructed, and assume that that is a safe building. We have to start thinking about the future and how those buildings will survive in future. Thank you.